Hello. Now we're going to look at question 7. It says, use the graph to the right to determine where the function is discontinuous. For each value given, list the condition or conditions that are not satisfied. Now, remember, there are 3 conditions. The first condition is that the limit must exist. In other words, it has to have a value, not infinity, and not just does not exist. The second condition is that the function value must exist. In other words, it has to have a function value. And the third one is that the limit, as x approaches that function value, has to be that function value. In other words, the limit has to equal the function value. So, looking at this over here, notice that wherever we have just curves, then those are all continuous. The only places where it might be discontinuous is, for example, a vertical asymptote or jumps or just holes in the graph and stuff like that. That's where discontinuities can exist. Now, oh, I forgot to put these values. I will fix that before I put this on here. So this is -1, 0, 1, 2, and we'll have 3 right there, and I guess -2 there. There we go. Now, notice that on here, -1 is in fact a vertical asymptote. And so as a result, the limit does not exist, because if you notice, it's going to either -infinity or +infinity. Even if they went up in the same direction or down in the same direction, it's still -infinity and infinity do not exist. At least the limit technically does not exist. So what we would say there is x equals -1 is that, and that's condition 1. The limit does not exist there. Good. So at 0 here, notice the limit from the left is that value. The limit from the right is that value, and those two limits are not the same. So x equals 0 is also a point of discontinuity. So, and that again, because the limit does not exist. So wonderful. Looking at 1 here, the limit from the left is here, the limit from the right is here. So that's happening the same way. So x equals 1 with the same condition, the limit does not exist. X equals 2. Notice that while there's a function value there, we still have almost a vertical asymptote on both sides. But notice that these two are approaching some value up here, possibly. But the function value is right here. So there's no way for the limit up here to be the same as this limit here. So I would say that this is actually condition 2. So for x equals 2, even it's probably condition 1, honestly, but condition 2 is probably the better one to say. There we go. And everywhere else, this is defined. Or this is continuous, I should say. Good. And that's question 7. Have fun.